Okay, kiddos, here is part 2, page 3 and 4 of our practice quiz. So, question 12, we have a 10-kilogram desk being pushed with some force over some distance. I strongly recommend drawing a diagram to help you visualize. This is asking how much work was done. So, work is force times distance. Notice how we didn't need this information. That's okay. But we multiply the force times the distance and end up with units of joules. Question 13. Rock climber wears some backpack. They're scaling a cliff. They climb for 30 minutes, and she ends up this high above her starting point. So we have a diagram. She goes from here up to here. And what we're interested in is how much work did the climber do on the backpack. So even though it's different from what you're used to seeing, this is like there's a hand, and the hand is applying some force upward on some thing. So that thing is the backpack, and the climber is exerting force upward. So, how much work did she do? Again, work is force times distance, and the force that she exerts is equal to the weight of the backpack. If it were accelerating upward, the force would be greater, but we can assume that she's climbing at a fairly constant rate, so the force upward has to balance the force downward, which we call weight. So, force she exerts is weight, which is mg. The distance through which she exerts the force is equal to 9.2 meters, and we multiply and get this. For question 14, Susanna walks up a flight of stairs. Would she exert more power if she walked slowly or quickly? So we have that power is equal to energy per time. Whoa, that's an E. So if this is less, this is more. Like dividing by a really small number makes this large. So if she walks quickly, that means less time, meaning more power. 15, which of the following is true about elastic and inelastic collisions? So momentum is always conserved. Kinetic energy is only conserved in elastic collisions. So I know that's, so elastic, we have kinetic energy and momentum be conserved, whereas in inelastic, it is only momentum that is conserved. For 16, 80-kilogram football player tackles a 90-kilogram football player, and they stick together. So if they stick together, that is inelastic. If they bounce, it's elastic. And no collision is truly elastic or inelastic, but if they stick together, it's definitely like this. Last question. We have a light train and a heavy train. We know that they're heading towards each other, but we're not told the directions, like which is which. Before the collision, they're both going 3 meters per second, so 3 meters per second, 3 meters per second. Now we don't know yet which is big and which is small, but we know that after the collision, the trains stay connected and move off in the negative direction. So if they are going this direction afterwards, we can assume that it was the big one that had to be moving this way and the small one that had to be moving that way because they're going the same speed. Okay, so the big one will have more momentum and will carry them in that direction. So this would be a diagram for before and after. Just by reasoning it out and drawing something like this, we could tell that the heavy train was moving this. Now let's see. Was the heavy train moving in the positive or negative direction? Should be moving in the negative direction like so. Diagram was just shown, And when we actually go to solve, so this mv plus mv equals mv plus mv. This is conservation of momentum, where we have before collision and after the collision. And this could represent the light and heavy, and then light and heavy. So I think the most difficult thing for students is recognizing that if they stick together, they're going at the same speed. So what to actually have is the variable. Our variable for velocity would be v, and because they're going the same speed, we can list the velocity of the light one and the velocity of the heavy one as v. These numbers give us this. Let's divide by that and end up with v equals that. And then using that velocity, find the total kinetic energy of the trains. So total, indicating kinetic energy of the light one and the heavy one, giving us this many joules, and we have a rounded answer.